All right, let's dive right into this. Welcome to today's Explainer. We are treating this session as your ultimate interview prep masterclass. We're going to completely demystify Spring Boot's core concepts. So whether you're heading into a crucial technical interview and feeling the pressure, or you just want to really solidify your understanding of how this framework actually operates under the hood, we are going to break it down step by step. Let's get right to it.
So here is our roadmap for today. First up, the Spring application context. Second, @component versus @bean. Third, singleton versus prototype scopes. Fourth, controllers and REST APIs. And finally, number 5, understanding auto configuration.
Okay, Section 1. The Spring application context, the heart of the framework. Picture this. You're sitting across from a lead engineer. The vibe is intense. And they open the technical round is a deceptively simple question. What exactly is the application context? Boom. It's a make or break moment, right? A lot of candidates actually freeze up right here. They know how to copy-paste annotations from tutorials, but this specific question tests if you truly understand the framework at its core engine level.
Well, here is your definitive answer. The application context is the central interface within a Spring application that provides configuration information. Honestly, just think of it as the absolute center, the beating heart of the Spring inversion of control, or IOC container. If we break inversion of control down to its absolute simplest form, it's basically this. Instead of you writing code to manually fetch dependencies and wire objects together, the container magically injects them for you. Literally everything flows through it.
So if the interviewer asks what it actually does, you're going to want to rapidly fire off these 4 main responsibilities. First, bean management. It instantiates, configures, and assembles your beans. Second, internationalization. It provides the message source for supporting multiple languages, which is an absolute must for global apps. Third, event publication. It broadcasts events to interested listeners, keeping your apps super cleanly decoupled. And fourth, resource loading, giving you a generic way to load files and URLs. Lock these 4 into your memory, guys, because they define the container's true power behind the scenes. Moving right along to Section 2, creating beans, @component versus @bean. Now this brings us to a classic, and honestly, a highly frequent point of confusion. When exactly should you use the @component annotation versus the @bean annotation? Nailing this one shows the interviewer you actually get the practical difference between automatic component scanning and manual configuration. And the secret here? The choice entirely depends on your level of source code control. Think of @component kind of like a crane. It's a class-level annotation used for automatic detection through class path scanning. You use this when you physically control the source code. You wrote the class, so, you just slap the annotation right on top. On the flip side, think of @bean as a delivery truck, bringing in outside parts. It's a method-level annotation used inside an @configuration class. You're going to use this when you need to instantiate a class from a third-party library, say an AWS S3 client or some custom security filter, where you literally cannot open their compiled source code to add that @component annotation. All right, Section 3, managing state, singleton versus prototype scopes. Let's take a look at the next prompt they'll likely throw your way. What is the difference between singleton and prototype scopes? This one is huge because it tests a vital concept, memory management. And let me tell you, getting this wrong in production is a fantastic way to completely crash your server with memory leaks. No pressure, right? The absolutely crucial point here is understanding data and thread safety. Singleton scope is the default in Spring. The container creates exactly one instance, and all requests return that exact same cached object. Because it's shared across all threads, it is strictly for stateless beans, like your services or repositories. Contrast that with prototype scope. This creates a brand new bean instance every single time a request is made. You'd use this when the bean holds user-specific state and absolutely positively should not be shared across threads. It's an interview-winning distinction right there. Shared and stateless versus unique and stateful. Just drop the term thread safety here and your interviewer will know you mean business. Okay, Section 4, the web layer, controllers, and REST APIs. A super common API development question you're going to face is what differentiates @REST controller from a standard @controller? It's a really great test of your practical knowledge when it comes to building modern, decoupled web applications. The math on this one is brilliantly simple. Basically, @REST controller equals @controller plus @respondingBody. Historically, a standard @controller was used for Spring MVC to return an HTML view page.
But to return raw data instead, developers had to manually paste the @RespondingBody annotation on every single method, which, let's be real, gets pretty tedious. So @REST controller was introduced as a massive convenience for modern REST APIs. It just assumes you aren't returning HTML. Instead, every single method automatically bypasses the view resolver and returns raw data, like JSON or XWRL.
And finally, Section 5, the ultimate magic trick, understanding auto-configuration. All right, this is the big one. How does Spring Boot's auto-configuration actually work? This question is specifically designed to challenge your understanding of the framework's most powerful, yet honestly most abstract magic feature. Interviewers want to know, do you understand the spell, or are you just blindly waving the wand? So let's strip away the magic for a second and define it clearly. Triggered by the @enable auto-configuration annotation, it attempts to automatically configure your Spring application based on the jar dependencies it finds sitting on your class path. By scanning what's already present, it drastically reduces the need for manual XML or Java configuration. It basically looks at your toolbox and makes a highly educated guess about the exact app you're trying to build. Let's ground that abstract concept with a real example. If you add the HSQLDB jar to your class path, Spring Boot's auto-configurer sees that dependency, and without you writing a single connection string, without defining a single bean, or writing a single configuration class, it automatically spins up a default in-memory database for you. It literally sees the tool, and it does all the heavy lifting instantly. And you know what? That right there is the true magic of Spring Boot. As we wrap up, I want to leave you with this final, somewhat provocative thought. Now that you understand the core mechanics, the application context, how beans are made and scoped, the web layer, and the magic of auto-configuration, ask yourself this. Are you letting auto-configuration do too much or maybe too little in your own projects? Because really, understanding these concepts isn't just about surviving an interview. It's about critically reflecting on your own engineering choices and taking true control of your architecture. Thanks so much for joining me for this explainer, and hey, good luck in those interviews.